Okay, well, not a huge crowd here, but I guess we'll get started. So this is mostly bound for our YouTube channel anyway. So there we go. So hi, my name is Mark Feit. I'm a principal software engineer at Internet 2, and today we're going to do a repeat of a presentation that I did at TechEx week before last. And this is all about pShooter, which is a tool we developed for doing automated troubleshooting with perfSONAR. So I guess we'll start by telling you a little bit about how all this came about. pShooter is a perfSONAR based performance troubleshooter. It has some automation features built in, which is really what it's for. And it came about as a result of some discussions that we had earlier this year around Internet 2 that really kind of centered around two topics. The first was how you add performance data to an existing visual traceroute tool. There were some meetings that happened earlier this year, and someone was showing off a traceroute tool, and they thought, gee, it'd be really nice to have performance information in it. The second part of it was how you identify perfSONAR nodes that are near points along a path. Now, initially, that was for trying to figure out where you'd get stored measurements, and we sort of changed gears on that a little bit. And I'll discuss that a little later. So I'm actually going to cover the second topic first, which is how to locate perfSONAR nodes, because that is actually sort of an important part of the process. So most of the time when you do troubleshooting, the first part of it is usually that you observe poor performance, or there's really nothing needed to troubleshoot. And then you'll usually do something like trace the path between the hosts and go figure out which perfSONAR nodes you're gonna go hit along the way to figure out where the problem is. Now, that third part is actually usually a little difficult, because the question is, where do you go make these measurements? perfSONAR operates a lookup service. It's got a lot of really useful data in it, but its big Achilles heel is that it's geographic and not topological. So what that means is if you're looking at a node that's physically up the street from you, it could be 5 or 6 hops away, and it might not necessarily give you good information. So when you have one of these candidate nodes, you have to go look at the path between it and the device that you're looking at, and you basically have to vet those nodes to make sure they're going to give you meaningful information. And it becomes a recursive problem, because you have to go find other perfSONAR nodes to go test out those paths and see if they're really useful for you. So the question I think that most people want answered is a pretty simple one, which is, my traffic passes through some interface on some IP address. What perfSONAR node should I use for testing to that point along that path? And you usually want a really simple answer. Here's a very fictitious perf2.nyc.foo.net, and we'll be using that a little further on in the presentation. But that's really sort of the question that we're trying to get answered in a very simple way. Network operators, of course, know what the answers are to these, because they're the ones that put all their infrastructure and their perfSONAR nodes in, so they know where all this stuff is. But they also probably don't want a whole lot of phone calls and emails asking about it. So we thought that it might be a good idea, in the interest of opportunistic laziness, to find a way to automate the asking of this question and getting the answers. And we found a pretty low effort solution in the domain name service. And a few people may be rolling their eyes and going, oh great, they're going to stuff more information into DNS. But in this case, we figured it was actually a pretty decent application for it. So we decided to go there. Why use DNS for this? 4 reasons mostly. Everybody's got it. It's reliable and robust. It's available all over the world. There's caching to help mitigate outages when the authorities are not able to give you a direct answer. And it's also very widely available. It's not too often that you can't get a DNS query answered, even if you're behind a firewall. Even if the path to port 53 is blocked, it's usually at least proxied by something, and you can get yourself an answer. We think this is also a better route to go than a single static directory. Nobody has to field any central resources and maintain them. Network operators control what goes into their DNS servers, so they can add things and remove them and change them as they see fit, without having to have logins somewhere else and all that sort of thing. And the other thing that's useful about this is that because of features like views that you find in bind, you also have the ability to give different answers to different questioners. So sort of the quintessential application for that might be if somebody is trying to do a test to a path that goes maybe into the network closet in the chemistry building, you might tell people who are inside your campus to say, yeah, go ahead and test to the perfSONAR node that's co-located with the switch inside the chemistry building. But you might tell people who are outside that they should really go test to the edge, and if they have a problem, then maybe they should call you up and talk to you about what they think the problem inside might be. So the way this scheme works, and this is, I should point out here that there is no magic in this. This is something that people are going to have to adopt. But you start with an IP along your path, and here's the same IP that we looked at a few seconds ago, and you reverse resolve that to its fully qualified domain name. So in this case, you get the fictitious e6-2.nyc.foo.net. Now, if you don't get to this point, nobody has set up to publish a recommended perfSONAR node for this, and you can stop right there. But if it does resolve, you can add a prefix to it. In this case, it's the highlighted part here. So it's this IPv4 perfSONAR.e62.nyc.foo.net. You take that, you resolve it to a text record, and what you get back is a little blob of JSON that says, here's the P scheduler that you should talk to if you want to do tests for paths that cross through this particular interface. If you don't find a text record, it means the operator hasn't published anything, and you're back to square one on what to use, but it was the same problem you would have had otherwise. There are some provisions in this scheme for different situations. So if you have single or dual stack IP environments, there are different prefixes for IPv4 and IPv6. There's also a last resort non-family specific prefix, which is just perfSONAR. You'll notice that we're using underscores there instead of dashes or anything else like that. That assures that the prefix versions are treated as domain names rather than host names, because underscores are not valid in host names. And this also follows a couple of conventions that have been established previously. We use the prefix largely to avoid colliding with any other applications of text records a site might have. We didn't want to tell them that if you want to participate in this, you have to abandon your own use of text records. We didn't think that would be a good thing to ask. We didn't think it would go over very well either. Additionally, there are some provisions that I haven't shown here, but they actually do exist for redirection queries to a URL. And the reason for that is that a lot of implementations of DNS have a 255 byte limit on the length of text records they'll serve up. Now, I figure probably most of these things are going to be a lot less than that. But should the data get bigger later, or we want to have something where answers are generated dynamically by whatever program you can put behind a web server to make the decisions about what to serve up. So it was just a little hook that we thought would be a good idea to put in there. So we did. So that's available as well. So the complete skinny on this scheme is available. We have about a 6-page document on how to set up DNS to work with this, and also what the algorithm is that pShooter uses to figure out what perfSONAR node to use to do its testing. I'll leave you the URL for that at the end of the presentation, so you don't have to scribble it down right now. We are going to encourage network operators to adopt this scheme. What we've done in the meantime, we've generated the data for Internet 2 and for a few other bits of selected infrastructure that I'll show you later. And there are actually hooks for using it without having to have people put stuff into their own DNS, while this is just a little science experiment. So that brings us to the fun part, which is the automatic troubleshooting, which is really what pShooter is all about. As we started to look at the proposed idea of putting all these performance measurements into this visual traceroute tool we were looking at, one of the things that we figured out pretty early in the process was that the traditional method of testing and storing everything ahead of time was really going to end up impractical, because if you're looking at a trace between two sites, things can change, the routing can change. You basically have to do measurements on every possible path segment along all points of the network, and it just becomes very big very quickly. So we decided even just for inside Internet 2, that would be huge, because we've got 34 or 37 sites. The other thing we discovered too is that measurement done ahead of time is probably not going to reflect what the network actually looks like when it's having a problem. So the decision was made that on demand would actually be a better way to go about this. So getting back to the troubleshooting process, a lot of the time, once you've got your path and you've got your list of perfSONAR nodes, usually the first thing you'll do is you'll test the entire path to make sure that you still have the problem that's being reported. And then you'll test shorter versions of the path until the problem disappears. And while that may not give you the exact location of the problem, it will at least give you some likely places to go look and see where it might be. So we know what the path is because that's just come out of a trace. That's pretty easy. We know what the measurement is that we're interested in. People who are complaining about throughput problems might, we might to look at that. We might look at the throughput results, or even we might look at latency to see what's going on there. And we also have the previously described way to find perfSONAR nodes along the path. And if you have all three of those, that means that doing a whole bunch of measurements along that path can be automated, and that's where pShooter comes in. So pShooter is, or will be, I should say, because it's a prototype right now, it's going to be a web service where you put a request into it, and you go off and get a cup of coffee, and results come back that have all the results of the testing. Underneath, it uses pScheduler's REST API to get the measurements done, and there are going to be lots of potential for integrating this with other systems. It's being built up as a web service specifically for that purpose. We didn't want to do something that was just specific to this one particular tool, so we decided to make it a general thing, because I like to do that because I'm all into reuse and things like that. Now, the state that it's in right now doesn't make for a visually interesting demo, so we're going to have a look in a minute at some stuff just on a terminal, but I'll try to make that as interesting and as visually appealing as I possibly can. So before we get started on that, let's take a look at pShooter from the outside and take a look at what goes into it. Really, it's two things. Number one is a list of IPs from a trace between the 2 points you're having trouble with. This is something that's very easily extracted from the JSON result of the pScheduler trace test. In fact, I'm probably going to add something to the REST API for this that will let you say, hey, go do a trace to this, and then kick off a set of pShooter tests to do it. The second thing that goes in is a pScheduler test specification template, which is just what you would normally pull out of pScheduler as JSON. The difference is it has special placeholders for the A and the Z end. So, for example, when you're doing throughput, the source of the sending end would be the A end, and the destination or the receiving end would be the Z end. So we'll dive into the demo. We're going to look at two things first. We're going to look at what a pScheduler trace result looks like, and we're also going to look at the input that goes to pShooter. So everybody can see the terminal here, I hope. If not, please sing out. Okay, so this is the result of the pScheduler trace test. I've stuck some comments in here because we'll probably distribute this, or this is actually being distributed with the prototype. Now, I should point out that all this stuff is actually canned data. I did that largely because I didn't want to have the topology of the network change while I was doing this. But this is all just as relevant as it would be if it were a live trace route that had been done 5 minutes ago. This one was actually done several weeks ago. But what you see in here is you see a set of paths. So you see in this case the first hop just had an IP and a round trip time. And then the second hop has a little bit more information in it. You've got the round trip time, you've got the IP, you've got the host name, and you've got the AS information. The thing that we really care about here is just the IP, and we're going to be pulling those out. And this just, quite simply, this just repeats over and over for each hop in the path. So you can see it does some stuff at MishNet, and then it jumps onto Internet 2's backbone, and it does a whole bunch of hops on Internet 2's backbone, and then it jumps into Cal State and Scenic and into UCSD, and it finally ends up at its destination. So the next thing we're going to look at is the input to pShooter, and you can see here there's a little piece of JQ that we just applied that pulls out this list here, which is the path. So what we're looking at here in the JSON are the two things that pShooter gets. One is a list of the hops that were in the trace with 127.0.0.1 added to the front, because you always sort of start at the local machine. That's just sort of a rule that pShooter established. And then the second thing is the second part of it is the test. And this is pretty much what we talked about before. Now, what I'm going to do here is a simple stream test. And the reason I'm going to do that is because if we do throughput, they're going to have to be done sequentially, and it takes a little while to get all those done. Whereas simple streams can run in parallel. So that's really just for time efficiency. The destination you can see here has our special little placeholder which is just _Z _. If you're going to specify a source end, you can do that as well. It would be _A _. Then we provide a little test material, which is just one of the parameters of the simple stream test. Now, if you're not familiar with that test, what it does is it just opens up a connection to a waiting socket on the far end, spits a little bit of data out through it, which is going to be what the test material is here, and then closes the connection. Both ends report on what they sent and what was received and what came through. So what I'm going to do here next is I'm going to actually start the process going, and we're going to run back to the slides for a second. But I want to talk for just a second about this line here that says building static resolver configuration. So I mentioned before, I put some hooks in this so that you don't have to go through and get everybody to put stuff in their DNS just during experimentation. So it's really just sort of the static resolver thing is just sort of a augmentation of DNS. If it's in our static data, we use that. Otherwise, we go ask DNS. Otherwise, we punt. And what you can see scrolling by here is pShooter going to establish all the measurements that it's going to do for this. So while that's cooking, I'll talk a little bit here about what's going on the inside while this happens. The first thing pShooter does is it goes and finds the nearest perfSONAR node for each point along the path. It uses either the DNS method that was described before, or it does a direct check to the IP on the path. And the reason for that is not real obvious now, but vendors are starting to put provisions in their devices so that we can run perfSONAR directly on the devices. So you would be able to run perfSONAR directly to test directly to them as well if you want it. The second thing that it does is it runs a test from itself to each point along the path where it finds perfSONAR is available. So for things like single participant tests where it's round trip time or latency, that can be run directly to the IP of the hop if perfSONAR is not available, because you don't need that anyway, because really all you need on the other end is ICMP for round trip time, or OMP or QMP for latency. For things like throughput or simple stream, because they're multi-participant tests, you have to have perfSONAR on the other end, pScheduler on both ends for it to work. So for a 2-participant test, it's going to insist that pScheduler is there. After all the tests have been run, the results get collected, some diagnostic information gets collected, and all that gets put together into a final result. So what we're gonna see next is what comes out of this. You get 3 things. You get the results of each test that was performed. And you get that in 3 different formats. You get it as the raw JSON that came out of pScheduler, if you want it in machine readable format, and it also comes out in plain text and HTML. The plain text, if you've ever used pScheduler's command line interface, this is exactly the same thing that gets spit out when you look at a result. Things like the throughput result may actually look a lot like the output from iPerf, but the sort of dirty secret behind it is that it's actually reconstituted from the JSON. You'll also get some information about the test, things like a URL where you can go ask pScheduler about it, and you'll get some details about when it started, when it ended, who was involved, how many participants were involved, all that sort of thing. Additionally, you'll get some information about what the hops were, what perfSONAR nodes were involved, and some additional diagnostic information that gets produced as part of the process. So we'll go back to the demo here and we'll take a look at what came out of it. And this is just the result of a little program I wrote that takes the complete result and dumps it all out in a nice, easy to read text format, using just the information that was in the JSON that was returned. So up at the top here, you can see that there was a test of 10.165.5.1, which happens to be the switch in the Ann Arbor data, or one of the switches in the Ann Arbor data center, or actually I guess it's the next router. And unfortunately, we couldn't get a whole lot of information about that. It didn't reverse resolve to anything. Therefore, we couldn't figure out what perfSONAR host to use to do measurements to that. So for that one, we had to punt. For the second one, however, we did a test of this perfSONAR node here, nmon-sfpop.mish.net, and we did that on behalf of this other thing at MishNet that we passed through, but didn't because it's a device, it doesn't have perfSONAR on it yet. We had to go ask DNS for who we should go test to for that. So what you see here is the result, and you'll see this repeated. But you'll see there's an amount of time that it dawdled before starting, which in this case is just no time at all. You get the text that was sent, the text that was received, and how long it took. And this is just all this, and we'll look at the raw result in a minute. This is all just stuff that came straight out of the JSON. So for the second hop, we had the same thing. After it was done at MishNet, it jumped onto Internet 2's backbone. And as it happens, Internet 2 runs Performance Assurance Service, which is a bunch of private perfSONAR nodes that this happens to have access to. So you can see here that we did, on behalf of this router here on Internet 2's backbone, we did a test to this perfSONAR node here. So it was test 2 on behalf of that. Same thing, we get the same results back. And this process just repeats continuously. So you can see for each hop on Internet 2's backbone, here's Equinix Chicago, and here's the same, excuse me, the same corresponding perfSONAR node in Chicago as well. And I'll just scroll down and show you the rest of these. Now, right at this point, we get into Los Angeles, and that's the last stop on Internet 2's backbone, and we actually get dumped off onto Scenic, or into Scenic's network. Now, here's one that came up that was actually sort of interesting. This is something that we had an IP address for, and we had a reverse resolved host name for it. But one of the problems with it was that it has an invalid character in it, which is this ampersand that you see right here. But because of that, we were not able to look up and determine whether or not there was a pScheduler there. So for that one, we had to punt. Similarly, here was another one. This was at Scenic in Los Angeles. This is another one where we had the name of the router, and we actually got a perfSONAR node to go test to. But when we asked it, we said, "Hey, we'd like to run this simple stream test," and it said, "No, thank you," and booted us out the door. So what you see here is just the diagnostic information that came as a result. And you can see here, for example, that they have a limit called innocuous test that said this is not in the list. Therefore, because we're testing from an address they don't trust, and they only let untrusted addresses do innocuous tests, we weren't in the list, so we got booted there as well. And similarly, if you scroll down, we'll look at the last few hops of this down here. This was sort of the same thing. We had a bunch of hops where we just didn't have pScheduler. And a lot of this would have been just stuff that I would have had to go run down, but I just put in a couple of bigger nodes just so it would be visible. So that's kind of the demo. I'm going to stop and talk a little bit about where pShooter is, and we'll talk in a second about where it's headed. Right now, it's a prototype. It's the command line program that you saw before. It does do everything that was described so far. As I mentioned before, it has hooks to augment DNS for doing experimentation. I was going to take those out when we take this to production, but I think I'm actually going to leave it in because I think there are some actual good use cases for that. If you have good intelligence about what perfSONAR nodes to use for a certain institution, and that institution isn't putting them in their DNS, then you'd be able to supply sort of this augmented information to use it for yourself. The code is designed and built to be ready for use in production without a whole lot of additional work. So the core of it is actually pretty solid. But where we need to go next with it is convert it. This process has actually been started, but it's going to be converted into a consumable service with a REST API, so you'll be able to integrate it with any program that can go fiddle with a REST API to do its business. And the perfSONAR project has decided that this is actually a pretty useful thing. So it will probably be integrated and shipped with a future release of perfSONAR, which, as I like to say, is being considered for a release that will happen sometime later than today. So that was all I have. I'm going to leave you with a few URLs. The first is for our short paper on how to use DNS as a locator service for perfSONAR nodes. And that describes both how you set DNS up and also how the algorithm works. The prototype that I was running can actually be run on any system that has VirtualBox and Vagrant available, and that's on my GitHub page, which you can see the URL for there. The prototype part of it will eventually disappear, and eventually, once it turns into production ready code, it will end up that'll disappear, and the production code will replace it, and it'll be folded into perfSONAR's development. So if you need more information, I'm going to pause in a second and ask for if anyone has questions. you can certainly drop me a line. I'm Mark Feit, mfeit@internet2.edu. So at that point, I think we'll open it up for questions if anyone has them. Quiet crowd.
I guess I'm curious, of the major RNE backbone providers, Internet2, ESNet, and some of the regionals, have you gotten folks to update their DNS records?
We actually none of this is in DNS yet, Brian. Internet2 has already committed to doing it because obviously I work there and I can sort of goad them into it. I would assume you know, the ESNet contingent on the perfSONAR project has seen this and they seem to think it's useful. So I imagine they'll probably go advocate for that as well. Really, I think we're not really at a point where we're ready to start marketing this thing yet, but I think probably there'll be a little bit of a marketing effort so that we can get you know, at least the backbone providers and the regionals to field this. And you know, I know University of Michigan has expressed some interest in it, so you'll probably see some campuses do this as well.
Okay.
Anyone else? Okay, well, as we like to say in the radio business, thank you both for listening. Again, if you have questions, please feel free to drop me a line, and be more than happy to answer them. But look for more information on this as it turns into a real product and gets beyond prototype. So, thanks again, and this will end up on our YouTube channel if there's anyone, you know, who needs to see this who missed it.